Imagine for a second that you can shrink down. I mean, way, way down. You're becoming microscopic, almost like something out of an old sci-fi movie, and you're about to take a tool inside the human body.
Hmm.
We talk about anatomy a lot, but usually it's abstract, right? It's charts and diagrams. Today, though, we're going to get visual. We're going to look at the difference, the really stark, undeniable difference between a healthy system and one compromised by disease.
And that's such a powerful perspective shift. Because usually when we discuss pathology, especially something like colorectal cancer, we're talking about statistics or treatments. But today is different. We're looking at the actual landscape. We're sort of exploring how experts use these very specific visual cues to identify problems from the inside.
Exactly. And we're not just winging it. Today, our deep dive is guided by a really fascinating breakdown from Dr. G.S. Raju's YouTube. This source is basically a masterclass in endoscopic visualization, and it's going to be our map for this whole discussion.
It's an incredible resource. And our mission today is really to decode those images. The source takes us on this comparison segment by segment of what the colon should look like versus, well, what it looks like when cancer is present.
And it's not just about spotting a lump, right? I think that's the common misconception. You just think, oh, I'm looking for a ball of something.
No, not at all. If it were just about spotting a lump, you wouldn't need years of medical training. It's about texture. It's about color. It's about, the structural integrity of the walls themselves.
Okay, let's unpack this. Before we start our tour through the different sections, because we are going from the cecum all the way to the sigmoid, we need to establish a baseline. The source lays out some general rules. So, broadly speaking, what are the red flags we're hunting for?
Well, the first thing that hits you, and the source emphasizes this right at the start, is the change in the lumen.
The lumen. Let's pause there, just so we're all on the same page. That's just the fancy medical word for the tube, right? The open space.
Correct, yeah. Think of the colon as a tunnel or a hose. The lumen is that empty space inside. In a healthy colon, that tunnel is wide, it's circular, it's open, but when cancer develops, the lumen becomes narrow.
So it's like a roadblock.
Exactly, a bottleneck. But it isn't just that the space gets smaller. The lining itself, the mucosa, that's kind of like the wallpaper of the tunnel, it gets replaced. Instead of smooth pink tissue, you see what the source describes as an ulcerated mass.
Ulcerated mass. I mean, that phrase alone paints a pretty vivid picture. It sounds raw.
That's exactly the right word. Ulcerated implies a breach. The surface is broken down. And that leads to the next key indicator, friability.
Friability. Okay, that word came up a few times in our research. I know friable usually means something that crumbles easily, like dry soil. What does that mean for human tissue?
It's actually very similar. If tissue is friable, it means it lacks integrity.
Yeah.
It crumbles or bleeds easily when you touch it. The source notes that this tissue just tends to bleed upon contact. It's unstable.
So if you touched a healthy colon wall, it would just bounce back?
Right. It's elastic. It's resilient. Yeah. But if you touch this friable cancer tissue, it just weeps blood. It falls apart.
That is a chilling distinction. And there was something else sitting on top of that mass, right? Something about a slough.
Yes, a yellowish slough.
Oof. Okay, that sounds visceral.
I know, it's not pleasant imagery. But that yellowish slough covering the ulceration is a major visual red flag. It's essentially necrotic tissue, dead cells, inflammatory debris. It stands out.
So it signals that the tissue isn't just growing, it's parts of it are dying off. Exactly.
So we have narrowing, we have this raw, bleeding, ulcerated mass, and this yellowish covering. But there was one more thing that I thought was fascinating from like an engineering standpoint. The source talked about the wall itself becoming stiff.
Right.
And this is where it gets really interesting. A healthy colon wall is flexible. It has to be to move things along. But the source points out that the wall can become stiff.
Yeah.
And the reason why is crucial.
Why does it get stiff? Is it just the weight of the mass?
No, it's much more insidious than that. The explanation given is that this stiffness happens when the cancer extends through the wall of the colon.
Oh, wow. So the stiffness isn't just on the surface. It's a sign that the problem has gone deep.
Exactly. It's an indicator of depth. The cancer has infiltrated the layers, the muscle, the connective tissue, and it's basically freezing that section of the wall in place. It turns a flexible tube into a rigid pipe.
It's like a criminal profile, but for biology. Okay, so now that we know what the bad guy looks like, let's go on this tour. The source starts us off deep inside, at the cecum and the ascending colon.
Right. So if you're visualizing this, the small intestine dumps into the large intestine in the lower right side of your abdomen. That's the cecum. Then it travels up. That's the ascending colon.
And the video shows a healthy view first. And what struck me was how the narrator described it. He calls it a nice, clean, healthy ascending colon. And he points out a specific landmark, the ileocecal valve.
That valve is the doorway between the small and large intestine. See it clearly, looking healthy. It gives you a sense of orientation. The tissue is smooth, the color is uniform. It looks quiet.
Quiet is a really good word for it. It looks peaceful. But then he flips the script and shows us cancer in that same area, and the difference is, well, it's night and day.
Oh, it's immediately apparent.
Yeah.
You remember that nice, clean tube? Gone. The source points out the lumen has become visibly narrow. You can just see the space closing in.
And the mass itself, it's not just a bump on the wall.
No. He describes it as a polypoid mass.
Polypoid. Help us with that.
Meaning it looks like a polyp is projecting into the space.
Yeah.
But unlike a small, benign polyp, this is actually obstructing the lumen. And true to the rules we just talked about, there is ulceration.
And the bleeding. He mentions friability with some bleeding.
Right. You can see the tissue is disturbed. It's not just sitting there. It's actively deteriorating. It's such a stark contrast to that clean ileocecal valve.
Okay, so moving along the tract, we leave the ascending colon and we hit a bend, the hepatic flexure.
The hepatic flexure. It's this sharp turn the colon takes right underneath the liver, hence hepatic.
Now, I have to say, the healthy view here provided my absolute favorite detail from the source. It was surprisingly beautiful.
I think I know what you're referring to.
The bluish hue. The narrator points out that in a healthy hepatic flexure, you can actually see the bluish hue of the liver right through the colon wall.
It's fascinating, isn't it? It tells you how thin and translucent a healthy colon wall actually is. It's basically a window. You're inside the gut, looking out and seeing the shadow of the liver.
It makes everything feel so connected. These organs are just pressed right up against each other.
Exactly. A delicate ecosystem.
But then we see the pathology, and that window gets shattered.
Completely. The view changes drastically. Once again, we have an ulcerated mass. The lumen is narrow. But there's a specific mechanical detail the source points out here.
He talks about the folds.
Yes, he says the folds of the colon are being pulled.
That sounded so visceral to me. Pull folds? What's happening there visually?
Well, the colon has these natural folds, almost like accordion pleats. They help it expand and contract. But the source explains that in this case, these folds are being physically dragged, distorted.
And why? What's causing that?
He gives the specific mechanism. It's due to fiber extension of the cancer into the submucosa and into the wall.
Okay, let's break that down. Fiber extension.
Think of it like a scar shrinking. When cancer invades those deeper layers, it creates this fibrous, scar-like tissue that contracts. It tightens, and it physically pulls the surrounding healthy tissue towards it.
Like a knot tightening in a rope.
Exactly. Or imagine pinching a piece of fabric and twisting it. The fabric all around your fingers gets pulled tight. The cancer is the pinch.
So when you see those folds looking distorted, you are literally seeing the cancer grabbing onto the wall and tightening its grip.
That's a perfect analogy. It is a visual representation of the cancer rooting itself deep into the tissue. It's digging inward and pulling the wall with it.
Terrifying and fascinating. It really shows you this is a structural disease. It's changing the engineering of the organ.
It's mechanical failure caused by biological invasion.
So we've seen the ascending colon, we've seen the hepatic flexure. Now we move down the other side, the descending colon.
Right. We're heading towards the exit now. This runs down the left side of the body.
And again, the source gives us that healthy baseline. Nice, healthy, wide open. I love how he says wide open. It feels like a relief after seeing those narrow passages.
It does. A wide open descending colon means things can move freely. It looks healthy.
But then the cancer view. And by now, if you're listening, you might be starting to guess what we see.
The pattern recognition kicks in.
Yeah.
The source describes it again. The lumen has become narrow. We see a polypoid mass.
And the texture.
Ulceration. And again, he specifically notes it is friable with easy bleeding.
It's amazing how consistent this is. It doesn't seem to matter where in the colon we are, the enemy looks the same.
And that's a key takeaway. Whether it's the right side or the left side, the fundamental behavior of the pathology, it manifests visually in the same way. It destroys, it narrows, and it bleeds.
And finally, we reach the sigmoid colon. That's the last section before the rectum, right?
Correct. The S-shaped curve at the end.
Healthy view.
Just a healthy sigmoid, normal functioning tissue.
And the cancer view.
You guessed it. Narrowing, polypoid mass, ulceration, friability.
It's relentless.
It is, but, that consistency is what makes endoscopic diagnosis possible. Imagine if cancer looked completely different in every single segment. It would be a nightmare to identify. But the source is showing us there's a reliable signature to this disease.
That's a really hopeful way to look at it. The disease is scary, but because it follows these rules, doctors can spot it.
Precisely. When the narrator points out the same features in the sigmoid, he's reinforcing that lesson. He's teaching the eye to spot the pattern.
So let's bring this all together. We've taken this tour, we've seen the nice clean walls, the bluish hue of the liver, and we've contrasted them with these angry, bleeding, narrow passages.
I think the power of this is in the details. It's easy to just think of cancer as a lump. But this deep dive shows us it's a process.
Right.
It's the process of the lumen closing. It's the process of the tissue becoming friable, losing its strength. The wall becoming stiff because the disease is pushing through the layers.
It turns a static image into a biological story.
Exactly. When you see that yellowish slew, you aren't just seeing a color, you're seeing cell death. When you see the pulled folds, you aren't just seeing a weird shape, you're seeing the tension of the cancer extending deep.
It really deepens your appreciation for what endoscopists do. They are reading a story written on the walls of our insides.
They are. And they're looking for those deviations from the nice, healthy, wide-open baseline.
I just keep going back to that bluish hue of the liver. Such a delicate image.
Yeah.
And to see it replaced by that stiff, ulcerated mass, it's just a stark reminder.
Yeah. And why understanding these visual markers is the very first step in being able to intervene.
Well, we have covered a lot of ground, literally, from the cecum to the sigmoid. It's been quite a journey.
It has.
To recap, we learned that colorectal cancer, regardless of where it hides, tends to follow this grim set of rules. It narrows the road. It replaces smooth lining with a friable, bleeding, ulcerated mass.
And it changes the mechanics, stiffening the walls, pulling the folds as it digs deeper.
It's a heavy topic, but knowing what it looks like, I don't know, it makes it feel a little less mysterious.
Knowledge is always the antidote to fear.
Right.
Understanding the mechanics makes it manageable.
Absolutely. And I want to remind everyone that this incredible visual breakdown came directly from Dr. G.S. Raju's YouTube. If you want to see the master at work, that is where this insight came from.
The truly invaluable resource.
Before we sign off, is there one last thing you want to leave our listeners with? Something to chew on?
I keep thinking about that concept of stiffness, the pulled folds. We tend to think of medical diagnosis as looking at the surface of things, like a rash on the skin. But this discussion reminds us that what we see on the surface is actually a map of the depth. The surface tension, the pulled folds, they are only happening because of what is going on beneath the layers. It's a reminder that in biology, form always follows function or dysfunction. The surface is just the tip of the iceberg.
That is a profound thought. The surface tells the story of the deep. Thank you for that. And thank you all for listening to this deep dive. Stay curious, and we'll catch you on the next one.